All right, so I think we're recording. Let's take a look and try and solve these three equations. These are rational equations. But problem number 4 is a little bit different than the other two because in problem number 4, this equation can also be referred to as a proportion that claim that two ratios are equal to each other. See, in number 4, you have a fraction equals a fraction. In number 5, you don't have that. You have a fraction plus an integer equals a fraction. And in number 6, on the right-hand side, you have the subtraction of two fractions. You don't have in 5 and 6 a fraction equal to a fraction like we do in number 4. So our technique to solve number 4 is going to be to cross multiply. With this negative sign here, I'm going to put it in the numerator. So I've got a divided by a minus 6. I have negative 2 divided by a minus 1. And I'm going to multiply along this diagonal and then multiply along the other diagonal. That's why it's called cross multiplication, because you're crossing over that equal sign, and we're going to take those two products and set them equal to each other. So multiplying along this red diagonal, we have a times a minus 1. Multiplying along this blue diagonal, we have negative 2 times the quantity a minus 6. So now let's apply the let's come back and say that I can't have 6 as a solution because 6 minus 6 gives me a 0 in the denominator. I can't have 1 as a solution because 1 minus 1 is 0, and that gives me, I can't have zeros in the denominator. Negative 2 divided by 0 is undefined. All right, so now let's distribute this a to both of these terms. We have a squared minus a. Let's distribute the negative 2. We've got negative 2 times a plus 12. So we have a quadratic equation. Let's get this quadratic equation in standard form. I like this a squared being here on the left. I'm going to add 2a to both sides. 2a minus 1 at here. Let's put a 1 there to visually help us. If I add 2a to each side, that one will cancel, and 2 a's take away 1a is just a. And then if I subtract 12 from each side, I have this equal to 0. So with the leading coefficient of 1 here, it's pretty easy to factor this. Although the X method is a fantastic tool to use when this leading coefficient is different than 1, it's really pretty easy to factor this because a times a gives us the a squared. And two numbers that multiply together to give us negative 12 but add together to get us a positive 1, we need plus 4 and minus 3 for that to happen. So this splits into two equations, and a plus 4 equals 0. Well, obviously, negative 4 plus 4 gives you a 0, and 0 times anything is equal to 0. And over here, 3 minus 3 gives you 0, and 0 times anything is 0. Well, negative 4 and positive 3 are going to be solutions to this equation. Neither one of them is going to give us a 0 in the denominator, so we're good. Unless, the only ways that these would not check is if I've done some type of arithmetic error. The technique doesn't require that I check these now because I know that the only way to have the extraneous solution would be to have division by 0. Now we see that later on in some type of equations, we are going to have to check, plug them in and check when we work with radical equations. But for these rational equations, yes, I'm checking to make sure that these aren't extraneous, but technically I'm not taking the time to plug it in to see if it satisfies the equation. I'm going to leave that up to you. You really need to do that, but in these videos, I'm just trying to help you to understand how to solve these problems, and I think I've done that for this problem. All right, ooh. Let's take a look at this next problem. Like I say, it's different than the first one. This is not a proportion. This is not the claim that two ratios, the two fractions are equal to each other. So let's come in let's look at 1 as 1 over 1, and we see that we have different denominators. We need a common denominator, and hopefully it's easy to see that that common denominator will be x plus 2 times x minus 2. So in this first term, this denominator is missing a factor of x plus 2. So we multiply by the number 1, but we write the number 1 as x plus 2 over x plus 2. Go to the second term here and rewrite 1 as 1 over 1, and you can easily see that we're missing both factors. So we need to multiply the second term by x plus 2 over x plus 2 times x minus 2 over x minus 2. So we're just multiplying it by the number 1, but it definitely is changing the appearance of this equation, but it's going to do that in a way that helps us to solve it, and that's by getting a common denominator. On the right-hand side, I see that I have a factor of x plus 2, and I'm missing a factor of x minus 2. If the numerator and denominator are the same, and the denominator is not equal to 0, then I'm multiplying by the number 1. That's what I want to do here. I can't change the value of these terms, or I would be changing the solution set to the equation. Let's go ahead and make our remark now that the values that would cause division by 0 are negative 2 and positive 2. So we have to make sure that when we get to that final solution that we don't make the claim that negative 2 is a solution set in the solution set or positive 2, because they make this equation, terms of this equation, undefined. And but now that we have the common denominator, if we multiply every term by that denominator, we're just going to deal with the equation that results in the numerator. So in this first term, if I distribute that 2, I have 2x plus 4, because both of these terms in x plus 2 get doubled. If I go to the next one, I have x plus 2 times x minus 2. That's the product a plus b times a minus b, which is a squared minus b squared, or x squared minus 2 squared, and 2 is 4. If I distribute this x to both of these terms, I have x squared minus 2x. When I look at both sides of this equation, I see an x squared term on each side. If you were to subtract x squared from each side, those cancel, and we just have the resulting linear equation. It's going to be pretty easy for us to solve. On the left-hand side, we've got 4 minus 4, which is 0. So we've got 2x is equal to the opposite of 2x. If I add 2x to each side, I've got 4x is equal to 0, or that x equals 0. I'm not afraid of a solution of 0. I am afraid if this value would cause division by 0. So the only two values that I was afraid of was negative 2 and positive 2. Hey, this problem, the solution set, x equals 0 is the only member of the solution set. If you plug in 0 into this equation, it'll satisfy it. Now, let's look at this last one, but I need to give myself some room to work, so I need to shrink this up. Hey, look at that. All right. Let's come down, change our color to red here for this one. All right, so when I see a variable in the denominators, I know I'm going to have to be concerned with division by 0. I know I want to find a common denominator, but to do that, I really need to factor these denominators that can be factored. On the left-hand side, I can't do anything with the denominator of a plus 2. But on the right-hand side, this first term, I can factor that denominator, and that factors to a plus 2 times a minus 2. And seeing this in factored form helps us quite a bit in making decisions about what to go for a common denominator. So when I look at these three terms, I want a denominator of a plus 2, a minus 2. on the left-hand side, I'm going to multiply this fraction by the number 1, but I'm going to write the number 1 as a minus 2 over a minus 2. The numerator and denominator need to be the same. On the right-hand side, this first term, it has the denominator I want, so I'm not going to do anything to it. And be careful that in my handwriting, my A's and my 2's look very similar. Sorry about that, but that is just the way that I write. I'm missing a factor in the second term of a plus 2. So if I write it as a plus 2 divided by a plus 2, I'm just multiplying that second term by the number 1. I'm not changing its value. So with a common denominator now in every term, if we were to multiply every term in this equation by that denominator, all these denominators cancel, and all we have to worry about is the numerator and work with it. So on the left-hand side, I have the product of 1 times a minus 2. I'm really fast at multiplying by the number 1. And that was a joke. And then here on the right-hand side, I have 4. Now, when you have subtraction, don't forget your parentheses. You're not subtracting the first term or the second term or your favorite term. You're subtracting all the terms. So on the left-hand side, I have a minus 2. On the right-hand side, I have 4 minus a minus 2. If I add a to each side, I have 2a. If I add 2 to each side, these negative 2's on each side cancel, and I have that 2 times a is equal to 4, and a is equal to 2. But remember, well, I forgot to look and make my comments here. When I look at this denominator, negative 2 would cause us division by 0. That can't be in my solution set. And also positive 2 can't be in the solution set. Well, that's what we got. Down here, we had a possible solution of 2. It satisfies this equation that was the result of the numerators, but in the denominator, we would never be able to set these numerators equal to each other, because in the denominator, in at least one of these terms, well, for all, when we have a common denominator, all those terms would have division by 0, and they would be undefined. So this is extraneous. It was our only candidate for a solution. So our final answer for problem number 6 is that this equation has no real solution. There is no solution to this equation. Hope that helps, and I will talk to you later.